small and closer to the Sun than any other planet, Mercury is where the extreme limits of nature are tested in ways that are almost unimaginable. With temperatures soaring up to 430 degrees Celsius during the day, hot enough to melt metal, yet plummeting to minus 173 degrees Celsius at night, cold enough to freeze steel. Along with this, Mercury holds the marks of the early solar system, recording fierce laws of nature. Composed of 70% metal, with its metal core making up about 85% of its radius. Mercury stands as one of the heaviest planets. The truth about Mercury is even more mysterious when we discover that this planet has a sodium tail stretching up to 2.5 million kilometers, an invisible streak only visible through modern technology. This is just the beginning. Now, we'll step into the world of Mercury, considered the most extreme planet in the solar system. We've seen the extreme temperature contrasts on Mercury. But in reality, this opposition goes even further, challenging the very logic of physics. This is Mercury's first and perhaps greatest mystery. With its unprecedented temperature swing, imagine this, in just one day, the planet's temperature jumps from 430 degrees Celsius, enough to melt molten metal, down to minus 173 degrees Celsius, colder than any night on Earth. This nearly 600 degree Celsius difference is a direct result of the planet's almost non-existent atmosphere. With no atmosphere to retain heat, all the solar energy absorbed is radiated back into space immediately once night falls. Mercury has almost no atmosphere. This thin air is not enough to trap the heat from the sun. So how can Mercury still have ice in a world with such extreme temperatures? It was the radar from the Arecibo Observatory that discovered something peculiar. Eternal water ice exists at Mercury's poles. Deep craters near the planet's poles create areas of perpetual darkness, untouched by sunlight, where temperatures remain frozen despite the scorching heat around the planet. These areas act like natural ice containers, where water could be preserved for billions of years without melting. Scientists hypothesize that ancient comets or celestial collisions in the past may have brought water deep into these craters. How can Mercury, a planet with almost no atmosphere, manage to keep water in these dark regions? We are faced with a mystery that goes beyond just the existence of ice on this planet. This opens up questions about the origins of life in the solar system, if Mercury can preserve water ice in these shadowed regions. Could we one day find traces of life in ice? Just as we found water traces on distant planets, the existence of water ice challenges logic, but to study it, scientists must overcome a greater physical challenge: the relentless gravitational pull of the sun. The journey to Mercury is a battle against gravity. As the increasing speed of the spacecraft when it enters the sun's orbit is one of the greatest difficulties. The sun's immense gravity continually pulls the spacecraft, accelerating it at an astonishing rate. This pull is so strong that without proper deceleration, the spacecraft would simply zip past Mercury and be drawn into the sun. This creates a problem no one could foresee when embarking on an exploration to this planet. BP Colombo, the spacecraft currently en route to Mercury, must cover a distance of 8.5 billion kilometers. And this is not just a simple trip to a planet. It's a challenging journey that requires the spacecraft to make 18 orbits around the sun, with 9 flybys of other planets like Earth, Venus, and Mercury. But why can't it fly directly to Mercury and instead has to take such a winding path? The answer lies in the sun's own gravitational pull. To slow down, BP Colombo had to employ a highly creative strategy, taking a detour to harness the gravitational forces of planets to reduce the craft's speed. Throughout this journey, ion engine technology plays a crucial role. This engine uses continuous blue light to generate gentle thrust, allowing the spacecraft to avoid being sucked into the sun while continuing its path to the planet closest to the sun. But this technology is not the only factor contributing to the success of BP Colombo's mission. As the spacecraft approaches Mercury to combat the extremely intense radiation from the sun, 10 times the radiation Earth experiences, BP Colombo is equipped with an advanced thermal shielding system made of ceramic. This system can withstand extremely high temperatures without damage, protecting the spacecraft's critical components. Especially scientific instruments and communication systems. The ceramic thermal shield is crucial in safeguarding the spacecraft from these effects. while also maintaining the stability of scientific instruments without overheating. However, the challenges don't stop there. Bepi Colombo not only has to avoid the intense heat from the sun, but must also contend with the extreme temperature fluctuations throughout its journey. Mercury's elliptical orbit presents a significant challenge in maintaining a stable temperature for the spacecraft. Bepi Colombo must rely on orbital strategies to help maintain its operational capability without overheating. Is there a way to maintain a stable temperature without relying on such a complex system? Bepi Colombo, with its modern technology and sophisticated orbital strategies, might be a temporary solution. But it's only the first step in studying and conquering the harsh physical limits of space. With current technology, the exploration of Mercury remains one of humanity's greatest challenges. Mercury is not just a planet close to the Sun. It's a natural laboratory where the laws of physics seem to be turned upside down. Deep beneath the surface of Mercury lies a physical structure that doesn't fit the pattern of any rocky planet. Imagine a tiny planet with a metal core that makes up 85% of its radius, making Mercury the second densest planet in the solar system, only behind Earth. Why does Mercury have such a massive metal core? Recent studies, particularly from the Bepi Colombo mission, have given us new insights into Mercury's internal structure. Data from the Bepi Colombo spacecraft is revealing that Mercury's metal core isn't just a solid mass. It's still hot, indicating that the planet has not fully cooled since its formation. One popular hypothesis for Mercury's origins is the giant impact theory, which suggests that in the early days of the solar system, the planet underwent an extremely powerful collision. This collision blew away Mercury's rocky mantle, leaving behind a dense and heavy metal core. Current research shows a surprising fact. When the Sun was young, its radiation power might have blown light materials off the planet's surface, leaving only the metal core beneath. This is a new discovery that helps us better understand the planetary formation process in our solar system. Another mystery scientists are trying to solve is the fact that Mercury is slowly shrinking. Large cracks on the surface. Like the Beagle-Roup's Ridge, are evidence that the planet has shrunk by over 14 kilometers during its history. This suggests that Mercury's metal core continues to cool and contract over time. Scientists believe that as Mercury's metal core cools, the planet began to shrink and crack. These cracks, or lobate scarps, are clear signs that the planet has experienced significant geological activity in the past. But beyond the planet's shrinkage, another issue causing debate in the scientific community is the existence of energy within Mercury. The question of Mercury's metal core remains a challenge. How has Mercury managed to maintain a hot metal core throughout its history? And can we truly understand the structure and evolution of this planet by studying the fluctuations within Mercury's core? We once assumed that Mercury was a barren, sun-scorched world, riddled with impact craters and completely silent, much like a distorted version of the Moon. But is this silence perhaps the greatest misconception in planetary science? Groundbreaking data from two major missions, the NASA's Messenger spacecraft and the recent Bepi-Colombo mission, a collaboration between Europe and Japan, have uncovered a startling secret. Mercury, in the dawn of the solar system, was not only boiling but has kept an internal fire far longer than we thought, making it a living witness to planetary geological transformation. Let's start with the Caloris Basin, a colossal impact crater with a diameter of 1,550 kilometers, a geological scar roughly the size of Texas. For a long time, it has been considered the clearest evidence of the solar system's late heavy bombardment. But is it just a simple impact crater? Detailed images have revealed that Caloris is not merely a basin. It is a vast fossilized lava sea. More importantly, at the center of Caloris lies an unusually deep network of fractures known as Pantheon fossae. Which has defied traditional explanations. These fractures radiate from a crater near the center, Apollodorus. Scientists believe that the explosive force of the impact created a shock wave that traveled across the entire planet, fracturing its fragile crust and allowing magma from deep beneath the surface to surge up, filling the basin and creating the smooth plains we see today. Before the data from Messenger, scientists believed that volcanic activity on Mercury ceased billions of years ago. However, researchers have identified regions with flat, smooth plains covered by a slick material. showing few small craters, clear signs of relatively young lava flows that erased older geological structures. Notably, the discovery of supervolcanic eruptions unrelated to impacts, such as Navoy Mons, has been a game changer. These eruptions occurred when volatile materials, things that seemed impossible to exist on a planet so close to the Sun, were heated by magma and expelled into space, forming pits or cracks on the surface. However, recent research has uncovered salt-like glacier structures in craters near the North Pole. Including prominent double-ring craters like Rachmaninoff and Raditladi. Planetary scientists believe these structures are not just salt, but may also contain other volatile compounds, trapped and preserved for billions of years beneath the surface. This is a revelation that completely changes our perspective. While Mercury's surface is as harsh as a furnace, these subsurface areas may be far more hospitable. Could these salt glaciers, which preserve essential compounds for life, create a stable environment capable of nurturing some mysterious form of microorganism deep underground, shielded from the sun's scorching heat? Compared to the Moon, a planet whose surface Mercury seems to mirror. Mercury has revealed a much more complex and dynamic geological history. Evidence of that ancient fire is still perfectly preserved in the form of fossilized lava seas, tectonic fractures, and traces of supervolcanic eruptions. Mercury was once a furnace, but what has allowed it to maintain enough energy in its massive metal core to create one of the greatest paradoxes? Could it be the magnetic field? Previously thought to be impossible due to its small size and high temperatures. Missions like Mariner 10 and Messenger have reshaped how we perceive this planet. Mercury does indeed have a magnetic field, although it is weak, only about 1.1% of Earth's. This came as a surprise to scientists, as theory suggested that such a small planet would not have enough energy to sustain a magnetic field. Mercury's magnetic field is asymmetric, with its magnetic center offset by 20% from the planet's physical center. Is one of the greatest anomalies among all planets with magnetic fields in the solar system. Why this offset? What creates a magnetic field that is so asymmetrical, unlike any other planet in the universe? Mercury's magnetic field mechanism involves the dynamo process, the flow of molten metal in the planet's core. However, unlike Earth, where a sufficiently large solid and liquid metal core generates a strong magnetic field, Mercury has a large molten metal core but lacks a strong energy source. Scientists believe that the Sun's tidal forces may be the key to generating the energy necessary to maintain Mercury's magnetic field. The tidal forces, created by Mercury's elliptical orbit, generate continuous physical waves that stir the planet's metal core, keeping the molten metal flowing and creating a weak but persistent magnetic field. One of the strangest aspects of Mercury's magnetic field is its misalignment. The planet's magnetic field is not only weak, but also so offset that it challenges existing geophysical models. This anomaly not only challenges current theories, but also opens up entirely new avenues of research into planetary geophysical mechanisms. Could Mercury's misaligned magnetic field be a manifestation of magnetic field formation processes in planets close to the Sun? Or is it just a unique case? Although this planet has no atmosphere and conditions for life seem impossible, Mercury's weak magnetic field might still create some of the necessary conditions for geological processes. Perhaps this field, despite its weakness, plays a crucial role in maintaining stability and protecting the planet from the intrusion of factors from deep space. Mercury's magnetic field may not be as strong as Earth's, but its existence could be the key to a deeper understanding of the development and structure of this planet. With the advent of Bepi Colombo and future missions, we may soon make unexpected discoveries about Mercury's magnetic field. Its weak, yet asymmetric magnetic field, along with the findings from current missions, will continue to help us gain deeper insights into this mysterious planet. Beyond its weak magnetic field, this planet interacts with the Sun in a unique way that's unlike anywhere else in the solar system. Without an atmosphere, yet it has a tail. Mercury lacks an atmosphere like Earth's, but in reality, it has a very thin exosphere. This is the layer of gas that is constantly bombarded by the solar wind. A stream of charged particles, blowing atoms from Mercury's surface into space. In this exosphere, elements such as helium, potassium, sodium, and hydrogen float around, creating a strange interaction between the planet and the Sun. But what's even more remarkable is this strange visual phenomenon that forms a glowing streak stretching millions of kilometers behind Mercury, turning it into a metallic comet for eternity. This glowing trail, called the metal tail, can extend up to 2.5 million kilometers. This is not a simple solar wind phenomenon, but rather the result of the solar radiation pressure force. Sunlight, through photon force, pushes sodium atoms off the planet's surface, creating the characteristic metal tail. This phenomenon is an extremely unique physical mechanism. While we know the solar wind can blow material off planets, it's the interaction with sunlight that is the main factor creating an endless tail extending from Mercury. What makes this magic happen? The answer lies in the photons from the sun, which continuously push sodium atoms into space. Mercury, a planet with no atmosphere like Earth, but with a metallic tail extending millions of kilometers, the interaction between Mercury and the Sun is not limited to material loss, but also reveals profound effects from radiation and the planet's orbit. Mercury's exosphere is not just a thin layer of gas. It's the key to unlocking answers about the interactions between the planet and the Sun. The surface of Mercury holds mysteries that can only be found here, serving as the clearest evidence that it defies all assumptions of a quiet, static world. This planet, barren and scorching, still maintains powerful movements at the molecular level. The Pantheon-Fosse structure, with its starburst-like network of fractures, continues to challenge theories of geological development. It is a testament to the internal stress from the massive metal core that still impacts the crust, showing an ongoing, albeit slow, transformation despite the harsh environmental conditions. This journey of exploration does not stop at curiosity. The Bepi Colombo mission will complete a map of Mercury's magnetic field and exosphere by around 2030. Promising a breakthrough in unraveling the big questions about its origin and evolution. Mercury is slowly changing, holding the answers to the formation of the entire solar system. The geological and chemical traces it leaves behind are not just phenomena, but keys to a deeper understanding of life and the evolution of the universe. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.